So hello everyone, today we are going to see weldments by using plates. It is also called as plate weldments. So to start with plate weldments, we have to understand what we are going to make. So we are going to make some welding structures made of different sizes of plates which are welded together. So in this lecture we are also going to see how to make welded structures by using manufacturing methods. This manufacturing method should be seen in your model tree also. So here the steps matter, at which point you are going to cut the part, at which point you are going to give the holes and everything. So we'll start with the part. For that I have taken this PDF here. So this is a small structure given here made of total 4 parts, that is 4 plates. First the bottom plate, then the second vertical plate, third the rib left hand side, and fourth the right hand side. So these are the parts or plates we are going to make, in which there are 2 plates and 2 gussets or ribs here. So to start with, I am going to make the base plate first. For that we have given the dimension, that is 63.5 width, 62 length, and thickness is 11 mm. So we'll start with the bottom plate first. So to start plate weldments, you have to select the weldments option or tab here. Then you have to go on weldments. First select this command for creating any weldments, whether it may be structure or plate weldments. It is compulsory to select this command first, then only the cut list will be generated there, showing the sizes of the plates or parts. So now after selecting the weldments, we are going to go for the planes and start making the plates. The making of plate is simple, that is by making it extrude boss and extrude cut only. But here what matters is that plates should not be merged with each other. They should be unmerged and should be shown as a different bodies. For that only this weldment tab is given. When you click on this weldment tab, each plate will be a separate body without merging with the other plate. So to start with, I am taking this top plane, say center rectangle here. To keep the planes in center, I am going to go for center rectangle 63.5, and this one as 62. So I am going to take this as 63.5 and this as 62. Say features and extrude boss. So the extrusion size here, it is given as 11 mm. You can see here. So we'll select this tab and say it as 11 mm. Then we have to say it OK. Now the procedure according to manufacturing is to make all the parts first, and then go for the larger cutouts for weight reduction, and then after that we are going to go for machining cuts, and lastly we are going to go for the holes, that are standard holes being shown here. You can see these holes, and this way you have to complete. So the order will be, first make all the plates as a structures welded on each other, and then we are going to go for these larger cutouts. This one you can see here, the big cutouts made for weight reductions. And then we are going to go for the machining cuts. You can see here one machining cut has been provided. So after this larger cutouts, then only we have to make this machining cuts, and lastly we are going to go for the holes. So this will be the procedure for making this part or a structure. So to start again, we have made this plate here. So now this face is coming in front position 63.5. Next we are going to go for this plate, the vertical plate. Height for the vertical plate from the bottom is given as 151, and the thickness here it is given as 12.7 plus 1.7 of the machining cut. We are not going to consider in this sketch the machining cut. We are going to separately cut this machining cut. So for now we are going to take this complete value for the thickness, adding this 12.7 plus 1.7. So 12.7 plus 1.7, 1.7. 12.7 plus 1.7, that is 14.4. So the complete thickness, that is 14.4. We are going to take this thickness for this plate. So I'll draw this part now. I'll say sketch to the back face of the plate. Then going to go for the rectangle. Here the width of the plate will be same, that is 63.5, and height will be 151 from the bottom plate. So I'll put up the value here as 63.5 and the height from the bottom as 151. So if you calculate the height for the particular plate only, then you have to minus this 11 mm thickness from 151. That will be 140 mm height of this plate. We'll make extrude. reverse direction, and we have calculated the extrusion that was of 14.4 mm. So we have not minus the thickness of this machining cut. That's why it is coming 14.4. So I'll take it as 14.4 mm as a thickness and then say it OK. So the other plate is also been mounted here, and you can see in Boss Extrudes each plate is unmerged with the other one. It is because we have selected the weldment procedure. Next we are going to take these ribs. So you can see the height of rib is given as 40, this one as 10, and the bottom side distance, straight distance is also given as 10. In the placement for the rib, we are going to see the other view here. So for placements, you can see the center of the rib is coming 4.5 mm from the right side, and the other one is coming center as 59 from the right side. So here the ordinate dimensions are given, you can see. So from this as a 0 reference, this will be 4.5 as a rib center and the other will be 59 mm. So I'll take a reference plane here at 4.5 from this face, right hand side, reverse the direction and say OK. And now on this plane I'm going to make this rib. So I'll draw one sketch. The distance is given here by 10 mm, horizontal and vertical straight distance, both 10 mm, and the height was given here was 40 mm for the rib. So I'll take this as 40 mm, and this bottom base size is given as 30 mm. So I'll take this one as 30. So now this sketch has been completely defined and we are going to make it extrude. And now the thickness of the rib here is given as 5 mm. You can see the thickness here. So I'll make it extrude by 5 mm from mid plane. So I'll take this as 5 mm rib and then say it OK. Again we are going to pattern this rib here. We can also make it mirror, but I'll go for pattern here. So for direction I am going to select this edge, and here bodies to be patterned, that will I'll show this rib. I've taken this as a body only, as all the parts are unmerged with each other in weldments. That's why I'm going to take here as a body. Select the required body, flip the direction, you can see the distance here. So I'll go for the distance as 54.5 in between distance. I don't want direction 2 to be taken here, and then we'll say it OK. Now both the ribs are also mounted. So all the parts are been welded here. The cut list is showing here as 4 parts. And now we'll go for the weight reduction cutouts. So after mounting the plates with each other, then only we are going to go for the cutouts here. So here the rectangular cutout is been given on this vertical plate. So we'll make this sketch here. I'll say it corner rectangle. This height as 55 mm. And this as 30 mm. Now I'll go for the center line and make this sketch symmetric here. Select both the lines, say symmetric from the center, and then we are going to see the position. So from bottom side as a 0 reference, the height of this cut is given as maximum 122. So I'll take this value from the bottom to define the height or position of this rectangle. I'll say it 122. Next we are going to go for this cutout, features and extrude cut. So I'll take this as blind and through all. Say it OK. We'll also make this cutout here. So this height is 26 and the width is 30 mm. And the position for the bottom start is 21. So we'll start with that figure. I'll say this one as sketch. Again go with the corner rectangle. I'll make this sides collinear with the edges so as to match the width of the cutout, and this height as 26. And the starting distance from bottom is 21 mm. We'll say it extrude cut again. Will be through all cut. Say it OK. And now we are going to go for this fillets given here, that is radius 5 fillet, 8 sides, means all 4 sides of this cutout and the other 4 sides of this cutout. The radius will be 5. So I am going to select here radius 5. Select feature command and then go for fillet. Say it 5 radius and then select the required edges here. Say it OK. Then we are going to go for this chamfer cutouts 5 by 45. So I'm going to go for this chamfer 5 by 45 on both sides. I am taking it on both the sides as here it was given as TYP means typical, that is to be understood as in such a way that if any chamfer value other than this is not given, then we can consider it as 5 by 45 as it is written typical here. You can see this word. So that's why I am taking both the chamfers as 5 by 45. Say it okay. Now we are going to observe this model tree here. So first we have made all the boss extrudes, then we have gone for the cutouts, and then we are taking this fillets and chamfer. So the order of manufacturing should be in such a way. While making this boss extrude 1 or 2, we would have made cut extrude 1 or 2 also there. But according to the manufacturing process, these cuts will not come with the boss extrudes here. That's why we have made these cuts later. And now lastly remaining are the holes, standard holes and machining cutouts. So before giving holes, machining cutouts must be given there. So to make machining cutouts here, I'm going to prefer this dimension here. So the depth of the machining cut here is given as 1.7 mm from the backside of this plate. Now what are the machining cuts? They are supposed to be given when any other part is to be mounted on this face. So there should not be any waviness between two surfaces of two parts. That's why machining cut is been provided here and on which the other part is going to be mounted. So whenever two plates are going to be positioned with each other in weldments, the surface of that two plates should be machined first and then only the mating should be done there. That's why these machining cuts are being provided. And for that only it is written here as mask these surfaces. It means we have to provide machining cuts on these surfaces. So we are going to provide this machining cut of 1.7 mm as we have taken the width already here. But we have done one mistake there. We have not given this clearance there. So we'll update this part and then go for the machining cut. You can see here I have made these two faces flushed with each other. So to avoid this, I am going to go for the editing of the feature and I am going to take here the start end condition as offset and say 2 mm gap at the reverse side. So the sketch utilized for this extrusion will be the same, but it will take 2 mm offset to start the extrude process and we will get the desired position of this plate. Say it okay. Now you can see here there is a 2 mm difference gap as shown in figure, and then we are going to go for this machining cut of 1.7 mm. So here the depth of the machining cut is given. Make this part to be oriented as we want by selecting the view box. Then go for the corner rectangle and then we are going to provide the values here. So I'll take this one as 133 mm and the depth of cut as 1.7 mm. Machining cut depth and then go for features and extrude cut. Say it okay. So this was the machining cut we required here for the other mating part which is going to be mounted on this face. Motive of machining cut just to avoid the burrs or irregular surfaces between two parts or plates. So lastly we are going to go for the hole commands. We are going to use standard holes here using hole wizard. So here 4 tap holes have been given with the distances as 0 reference. This one as 21.3 and the other 51.3 from the bottom. So this distance is given as 30 mm and the other one is also coming as 30 mm. We'll go for this tap holes. The size of the tap hole here is given as M5 into 0.8. Now how to judge whether this hole is tap hole or some other hole? You can see here always for the tap holes the symbol is given here as 2 circles concentric with each other. One is dotted and the other one is solid. And other thing you have to recognize for the tap hole is always this pitch value will be given there. That is size will be given in metric, that is M5. That's why it is coming M here. And then into sign will be given showing the pitch value. So for the internal circle we can say M5 minus 0.8, that will be 4.2. That is the diameter of this internal circle. And for the external circle the diameter is of 5 mm. And with the similar size we are going to go for hole wizard. You don't need to say it sketch for the hole wizard. Just select the required face, make it normal and then go for hole wizard tab. Select the required size. So for tap holes we are going to go here. That is in straight tab type. Say custom sizing. And here we are going to select tap holes. Size here was given as M5 into 0.8. I'll select this size M5. Here 0.8 is not given, so don't get confused. You just need to put on this option, that is show custom sizing. And when you minus this 0.8 from M5, the internal circle value we were getting here was 4.2. So we just need to check whether it is coming here as 4.2, the internal diameter or not. So it is showing 4.2. So we don't need to make any change here. We'll just make it taper at the bottom and then go for the position. Select the required face on which you have to put up the holes. I'll select this face and place this hole here. Select smart dimension and I'm going to give this value as 21.3. Now the reference is taken as this one, this edge here. So I'll select this as 21.3 mm position. And this distance was given 16.75 from the left side. So this one has 16.75. So after positioning the holes, say it OK. And then we are going to go for linear pattern here. So now all the 4 tap holes are being provided. Next we are going to go for these holes. So these holes are nothing but dowel holes. So how to understand whether these holes are dowel holes? You can see here fitment with tolerance value is given here. So this fitment with tolerance value is only given for the dowel holes. So here the dowel hole is of diameter 5, fitment as N7. So I am going to go for hole wizard and the position here it is given as 36.30. So I'll go for hole wizard again. In third type there are subtypes given. So you can see here dowel hole, standard I have taken ISO and diameter here I have to take as 5 mm. And then go for the types of tolerance, that is fit with tolerance. So after selecting fit with tolerance, I need to give fitment for the hole. So I'm going to go with this symbol here. You can see the drop down menu showing the fits. So the fits was given here as N7. So I'm going to select the standard fit here as N7. We'll go at the bottom, say N7 fitment here. You can see the standard values by the N7 are by default coming here. Minus 0.04 and minus 0.016. Both the values are coming as we have selected the standard N7 here for the fitment of the hole. Then go for the position. Select the required face. Position both the holes here. Said OK. And now the dowel holes are also been placed here. Next we are going to go for the holes on this plate. So for that we are going to refer this view here. So here you can see simple drill holes are given. If there are simple holes, there will not be any fitment or tolerance given here. Maybe tolerance will be given at some cases, but fitment will not be given here. So you can judge this as a simple hole, and these simple drill holes will also be shown every time with this diameter symbol here, with 6.6 diameter and through end condition. So here 4 holes are been taken, first, second, third and fourth, with diameter of 6.6 and end condition as through. So we are going to make these through holes first and then we are going to go for this last 2 holes. So here I'm going to take hole wizard, third type, say drill size holes with diameter as 6.6, end condition as through all. Say position and select the face required and give the required holes here. And now the holes are been positioned and been made there. So these were simple drill holes. Now we'll go for dowel holes. So for dowel holes the sizes are given here. We'll consider this PDF. The diameter of the dowel hole here is given as diameter 6. 2 holes are been given there and N7 fitment is also given there. And condition for that holes are through holes. We'll go for this dowel holes here. Select hole wizard. Select the required type of hole. So I'll go for dowel holes. In third type, the subtype is given dowel hole. Say diameter as 6 and fitment with tolerance, that is N7. Position, say face selection and place this dowel holes here. So from the bottom this is 57 and the upper hole is of 132. I'll take this dimension as 57 from the bottom and this one as 132. And the position from the left side is given 31.75. So I'll give this horizontal dimension to 1 only, 31.75, and the other will be made vertical relation. Now these whole positions are also defined, say it OK. And now this plate weldment structure has been completed here. So these were plate weldments. So we have made this structure by following all the manufacturing steps. That is, first boss extrudes, then go for the larger cutouts, then go for the machining cutouts, and lastly go for the standard holes. So in this way we should make these all parts. So we have completed the weldments here. Now in next lectures we are going to cover drafting, complete drafting in 4 to 5 lectures. And for previous things such as part modeling, sketcher, assemblies, sheet metal and weldments, you can refer to the playlist on the YouTube by the name of 4 Dimensions Infotech. So please like the channel, follow the channel for more videos. After completing the SolidWorks, we are going to go for Solid Edge lectures also here. Till then, thank you.